Welcome back, y'all, to some more geometry. Talking about checking if it's a parallelogram. Now, all we are doing this whole section right here is kind of like a big old converse to 6.2. All we're gonna do is just work it out backwards, saying, all right, before we're saying if the quadrilateral is a parallelogram, then this stuff is true. We're gonna work it backwards. If this stuff is true, then that proves it's a parallelogram. So it's one big old proof done with just good old algebra. So for example, again, like we said, if the quadrilateral meets at least one of the following conditions, then it's a parallelogram. Easy as that. Let me fix this right here. Looks a little odd. There we go. So for example, here, this first one we're going to do is if we can prove that both pairs of opposite sides of a quadrilateral are congruent, then that proves the whole thing's a parallelogram. So what you're going to be doing is just working that out. Well, let's see. Again, we'll say opposite sides are equal. So we'll say 2x plus 3 equals x plus 7. So we solve that for x, and then we do that for y as well. So y plus 11 equals 3y minus 5. So as far as the homework's going to be, you're literally going to be just looking for the value of certain parts right here. So here we'll subtract by x minus 3 minus 3. We end up getting x equals 4. Easy peasy. For y, well, minus y plus 5 plus 5. Bam, bam. We're left with 16 equals 2y, so y equals 8. Easy stuff. So next one, talk about sides. Same thing with angles. If you can prove the opposite angles are congruent, then your quadrilateral is a parallelogram. So take a pause for a second. Go ahead and try this one. All right, so we got 8x minus 8 equals 6x minus 14, and then 6y plus 16 equals 7y plus 2. So we'll start the first one. We'll minus 6x plus 8 plus 8. We're left with 2x equals 22 divided by 2. X equals 11, y'all. 11. And with y, we'll subtract 6y from both sides. Subtract 2 from both sides. We're left with 14 equals y. Look at that. Good job, y'all. Next one right here. If we can prove the diagonals bisected each other, then that proves the quadrilateral is parallelogram. So we're going to go ahead and say that, hey, we're going to go ahead and assume this equals to this, and then this equals to this, and then set those equal to each other. So according to this, AP equals 3x minus 1, so 3x minus 1. BP equals 4y plus 3. DP right here is 6y minus 2. And then CP right here is 2x plus 3. So we got to find the value of x and y that proves the whole thing equal. So we'll start with that. We'll start with the x's. We'll say 3x minus 1 equals 2x plus 3. And then for the y, we'll go ahead and set it up. 6y minus 2 equals 4y plus 3. So we'll start with the x's right here. So minus 2x plus 1 plus 1. So we're left with 2x equals, not 2x, sorry, 1x. That's my bads. 3 minus 2 is 1. So x equals 4 right there. And let's look at y. So we'll subtract 4y minus 4y, add 2x to both sides. Or add 2, not 2x. We're left with 2y equals 5. Ooh, we divide by 2. Y equals, what is it, 2 divided by 5? That'd be 2.5, or just 5 over 2. Still be right, either way. All right, last thing down here. If one pair of opposite sides is both parallel and congruent, then the whole thing is a parallelogram. Okay, so these two lines are parallel and congruent. So if one set, we can just show one set. It's all it takes, at least one set. There's no real proof to this because there isn't. It's pretty straightforward like that. So that's it, y'all. That's all you're gonna have to do right here. So remember, as long as one of these things is true, it proves the quadrilateral is a parallelogram. So if you can show both pairs of opposite sides parallel, then it's a parallelogram. If you can show both pairs of opposite sides are congruent, it's a parallelogram. Both pairs of opposite angles are congruent, it's a parallelogram. If you can show the diagonals did bisect each other, it's a parallelogram. And last one, if you can show that one pair of opposite sides is both parallel and congruent, that proves the whole thing a parallelogram. So let's kind of practice that. Is this a parallelogram? Yes. We have both pairs of opposite sides parallel. Is this a parallelogram? Yes. One pair is both parallel and congruent to each other. Is this a parallelogram? It's a no, because it only tells us that one pair is congruent, but we don't know if they're parallel, and we don't know anything about the other side. Is this a parallelogram? This one's a no as well, because it only shows that one of the diagonals is bisected and one pair of opposite sides are congruent. It doesn't have the right thing right here. What about this? Does this prove this is a parallelogram? This one's a yes. Both pairs of diagonals are bisected, and it shows both pairs are bisected. On this last one, is this a parallelogram? We're going to say no. The reason being because one of the options are these consecutive interior angles, though. It has to be, again, both, as I said before, we have to show opposite angles are congruent, opposite sides are congruent. We don't know if anything's parallel here, so that's a no. Hopefully that helps y'all. Have a wonderful rest of your day. Let me know if you need help.